Thank you, Peregrine.
Right. Well, to repeat, welcome and good evening to friends, colleagues, and guests from around the world, as I hope we'll have as many people from as far afield as we have nearer to home. This is the first of what promises, I think, to be an interesting and fascinating, indeed, series of talks organised by the Commonwealth Heritage Forum, of which I should say I am also happy to be a trustee. And for further details of forthcoming talks in this series, do visit the Commonwealth Heritage Forum website, and I encourage you to join these as well. But to return to this evening, it's my huge pleasure to introduce you to my friend and fellow Jamaica-phile, Andrew Smith, an eminent conservation engineer, and who's going to talk on cast iron structures on the island of Jamaica. Principally two major structures from the early 19th century, and then a variety of other cast iron artifacts up to the early 20th. Please, during the talk, do feel free to send any questions to the chat box, and I hope Andrew, he said he will be prepared to address these at the end of his talk. So without further ado, Andrew, may I hand over to you to give us your talk.
Thank you very much, Peregrine. I apologize for my voice. I cannot clear it properly as I would like, but I just hope you can all hear me properly. We can perhaps clear up any misunderstandings in the questions. Okay, Rachel, if you could put the slides up for everybody.
Yes, we can see the slides. Thank you, Andrew.
Oh, right. Okay. Well, until relatively late in the colonial era, all cast iron was brought to Jamaica from somewhere else, almost entirely from Britain, rather than being produced there. Although relatively cheap in relation to the British economy, the weight and the subsequent cost of transport of cast iron made it considerably more expensive in Jamaica in relation to the island's economy. Alongside cast iron, other forms of iron were also imported. Wrought iron and crucible steel for edged tools and more domestic ironware. But their production or working doesn't require an industrial scale, but can be done on a relatively small blacksmithing scale, fired by charcoal. And so the ability to produce the tools such as machetes, hoes, picks, and other agricultural necessities was soon developed on the island. Large estates would have had their own blacksmith's forge from early on in their exploitation. However, Jamaica was unable to produce its own cast iron. And that's because in order to smelt iron from its ore, you need the ore, a flux, of which Jamaica has plenty because limestone is the preferred mineral, and a fuel capable of heating a considerable volume of material to around 1200 degrees centigrade, which is a brilliant orange heat. Coal and coke can achieve this temperature, but not charcoal. There is no coal on the island, and although there are small deposits of iron ore, these outcrop on the slopes of the Blue Mountains and have never been economically exploited. However, there is evidence that later in the 19th century, some iron was cast on the island on a really small scale using imported coal. Oops. The imported cast iron structures include two really very significant artifacts. This is the 1802 Iron Bridge, still largely intact and still largely original. It's probably the fourth or fifth oldest surviving iron bridge in the world, but of those, it's the only one which is still essentially in its original condition. All the others have required very substantial repair. Now, that is almost certainly due to the stability of its abutments. Iron bridges don't often fall down by failure of the iron, but they quite often fall down by failure of the abutments, either foundation movement or rotation or something like that. So the abutments here, which were entirely built by Jamaican people, have stood the test of time despite earthquakes and floods and everything else. And you can see they are very substantial structures in their own right. The next structure I'm going to talk about in more detail is the splendid former Royal Naval Hospital in Port Royal. Again, all imported and put together on the island to surround a series of brick-built ward blocks. Eventually, first of all, there were 3, and then the hospital was expanded in 1824 to create 6 ward blocks. And it's still there. It's much loved by the local people of Port Royal because it stood up when they sheltered the inhabitants of the town in 1951. I forget the name of the hurricane, but the town was very badly damaged, but the hospital stood against it. And I believe until recently, there was an inhabitant of the town who had been born in it during the hurricane. That does tend to endear a building to people. However, it's not just sort of really high class structures that were imported. There's a substantial military involvement, obviously, in Jamaica. As you know, Jamaica was first colonized by Spain, and then after Britain failed to capture Hispaniola as part of Oliver Cromwell's Western design in 1655, the forces turned their attention to the easier target of Jamaica, and not without difficulty, eventually managed to capture the island. And ever since then, the island's strategic position in the Caribbean and later the wealth it produced meant it was at risk of being recaptured, initially by Spain and later by France, following Spain's decline as a naval power. And so significant defences were constructed around the island, and they continued to be maintained and adapted until after World War II. The sequence began with Fort Cromwell, started soon after 1655 to defend Port Royal and Kingston Harbour. Cromwell was renamed Fort Charles fairly shortly after the restoration of the English monarchy in 1660. Anyway, up until the 20th century, these defences were maintained, updated, and added to spasmodically as threats were perceived. And of course, they all needed cannon and guns of various sizes, probably almost all of cast iron, though the later ones might have been of cast steel. This example is in Fort Haldane, which was built around 1760 to guard the port of Port Maria on the northern coast, north coast of Jamaica. The gun is not from the 18th century. It's clearly a 19th century gun. Both the gun, the carriage it's on, and the frame, the recoil frame that the carriage runs on, are all of cast iron, which is why they've stood up to the weather, maritime and wet, without too much corrosion. That military history includes what seems now the rather bizarre episode of Admiral Rodney. He was celebrated by the British settlers of Jamaica for his actions defending the island, and of course it's their lucrative share in its trade from capture. He first of all prevented an attack on the island by a joint Franco-Spanish fleet in 1762. And then on the 12th of April, 1782, the ships under his command defeated a French naval force off Dominica, which saved Jamaica. And at that point, a grateful House of Assembly voted a substantial expenditure on this memorial, complete with iron railings from Britain and a cannon captured from the French. These are in fact bronze cannon, not cast iron cannon. And whether today's Jamaicans think Rodney deserves all this pompous glorification, preventing one enslaving colonial power from taking over from another, I think is open to question. But it's there, and it forms part of that magnificent ensemble, Emancipation Square, which is the historic center of Spanish Town, now sadly neglected, with two of its four sides occupied by burnt out and only, well, not really maintained ruins. And it's a great shame, because the square should be the centerpiece of Jamaica's tourist heritage attraction. But Spanish Town's got its problems, and everything there is, well, sadly neglected. The earliest cast iron artifact whose date is known is also one of the most remarkable, the Iron Bridge of 1802 across the Rio Cobre in Spanish Town. Well, it's now in Spanish Town, but at the time it was just outside. It's also been very well studied, so its history is known in some detail. Much of that thanks to Suzanne Frances Brown, a journalist, broadcaster, and historian from the University of the West Indies. She and her brother Peter, an architect, wrote a monograph for the University of the West Indies, the Caribbean School of Architecture, which was published in 2005. And they needed his assistance with the English end, because obviously the ironwork excuse me, was built on the president's already pre-existing bridges in Britain. And I was able to help both of them find archive material that, well, was incorporated in the book, which explained the genesis of the bridge's design. You would have thought, because the bridge was built to speed up transport and commercial exchange between Spanish Town, which was then the island's capital, and Kingston, which had by then the most important port on the island. I don't know how many of you have seen Kingston Harbour, but it's an absolutely magnificent natural harbour, huge, and with areas of really quite deep water. It has a very narrow entrance, and so it's on the whole really quite calm. So Kingston Harbour was not only, well, it was also a focus for trade, but also, of course, it was a military target. And what another of the roles of the bridge was to facilitate the movement of military forces around the island, particularly in that very sensitive area. So you might expect that both the estate owners, the infrastructure on which they relied was going to be improved by this bridge, and the people governing the colony would have thought it was a very good idea and just get on with it, but not a bit of it. As you can see from this table adapted from Suzanne's book, that it took 35 years from from the earliest proposal to construct a bridge to actually getting the iron bridge open. One of the remarkable things about it is that the 1799 Act of the House of Assembly authorised the procurement of a stone bridge. And yet in October 1800, a York, UK newspaper reported the trial erection of an iron bridge, the Walker Brothers Foundry in Rotherham. And nobody has been able to find any documentation which explains why this change happened, or how this change happened. Its components are not that simple, as you can see. The whole thing needs to be broken down into manageable size and weight, so they can actually be transported around, well, first of all, handled, lifted, and moved, and that kind of thing, and then transported to Jamaica. And that happened in England. That wouldn't have been too difficult. That these things could be loaded onto a barge on the River Don, straight out of the Walker Brothers Foundry, and then transshipped in Hull into this, the ship, the Ellison. I haven't looked up anything about it, don't know how big it was, but obviously it had the capacity to carry several hundred tons of iron out to Jamaica. This drawing by Oliver Cox, an English architect who spent quite a lot of his time working in Jamaica with his wife, Jean. They were both fascinated by the social structures of Jamaica. Jean was a social scientist, and they came up with a series of proposals for not just the Iron Bridge, but also for the Royal Naval Hospital at Port Royal, and schemes of urban design and urban renewal and so on. I think some of them actually got a bit done, but not necessarily all of it. So to give you some sense of the pieces, these are all the components of the deck. They're not, they don't show the arch frame itself. And this elevation of the ironwork, taken from a paper written in the 1980s, as you can see, it was drawn from measurements and photos supplied by D.H. Wint. Now, I don't know who Mr. Wint was, or Mrs. Wint, perhaps, but it's the only formally drawn elevation of the bridge that I've seen. And just very briefly to talk about the bits of it, obviously it starts off with the arch rings at the bottom, and that's divided into a series of cast iron voussoirs with a half width one at the center, and then, which was the first one to be laid on the centering for the bridge, and then a series of regular, repetitive iron castings out from there. And then, because the slope of a bridge erected directly on the arch ring would have been too steep, they then have these series of graduated rings, which are called the spandrel panels. They support the deck, and you can see there the fascia between these balustrade stanchions, and then above that is the balustrade itself. So those are the four principal sets of components of the bridge. As had been standard practice in carpentry for centuries, the whole frame underwent a trial erection in Walker Brothers' yard. And when they got everything to fit nicely, with very understandably and wisely, they marked everything, so he'll put it back together again in the right order. And I was slightly surprised that the marks, these on the bottom rib of the arch voussoirs, that the marks were still so clearly visible. You can see how little corrosion there has been between of the ironwork, and you can see how tight fitting the joints between the voussoirs are. And that's essential because the arch essentially stands up by compression in those arch rings. And so if there are errors in the mating of the components, load will not be transmitted evenly. It'll end up in one rib or the other, and that will cause problems. So everything was very carefully fitted together with files and so on, and then marked so it could be put together again at the end. Just to go back, that is where those marks were. Those are the voussoirs whose marks I've photographed, and that's getting close to the north abutment of the bridge. The designer was this man, Thomas Wilson. He built several cast iron bridges. This one this is the only one that carries his name, and the date 1800. He calls himself an engineer. Obviously, he felt he could claim this as his bridge in a way that he didn't feel he could claim the others. He was quite successful for a few years, particularly after his design was used for a very large span bridge for the day, a 236-foot span bridge over the Tyne at Sunderland, which lasted right into the 20th century, but not without substantial modification. He came from the north of England, and maybe he expected to have nice firm materials on which to found his bridges, because when he started designing bridges in the fens, in the squashy soils of East Anglia and the much softer soils of the Thames and so around the Thames, two of his major bridges fell down in the later part of the first decade of the 19th century, and obviously that finished his career. But you can just see here the half-width voussoir piece at the center of the bridge. Oliver not only sketched the components, he also produced a series of 10 sketches showing the erection process of the bridge, but unfortunately there's not time to go through them properly today. The one thing I would disagree with on this sketch is that Oliver has supposed that the components could be brought up by boat. I think that's most unlikely. If any of you have seen the bed of the Rio Colbury, it's not like that. It flows fast, and there are frequent large rocks. And when the rocks are covered, it's flowing even faster, as you might expect. But anyway, you can see Oliver's tried to imagine the scene as it would have unfolded in 1801. The bridge is generally in good condition, but it has got a few defects. Here, looking up at the underside of the deck, one of the deck plates was broken at some point and formed a hole in the roadway. This was infilled over some wooden planks, as far as I can see, quite thick planks. But of course, you can't get them to maintain them, so they've decayed. And in the middle of the left-hand photograph, you can see the neck of a drink bottle that's been washed into the hole in more recent times. You can also see the frequent wasps' nests and so on under the bridge. So it's a bit hazardous getting down under there, but Dr. Ivor Connolly, who accompanied me down there, turned up a ride with a very large spray can of insecticide. The right-hand one just shows the last spandrel ring where it's built into the abutment stonework. And you can see it's cracked, but the cracks in the ironwork are all of that sort of nature. They're really not very wide. And luckily, the components have stayed aligned so that some of the forces can still be transmitted. The one part of the bridge that does concern me is the south abutment. You can see there, the ironwork as it goes into the stonework is really quite severely corroded. And the stonework itself is now quite, it has a lot of open joints so that water can get in. And well, in fact, in this case, there's a bee's nest in there behind the ironwork. So we didn't go quite as close as we might have done otherwise. But the ironwork goes on. We can only see about half that voussoir piece. So it continues for another another one upright into the iron. And we don't know what that last voussoir sits on, whether it sits on a bearing plate or a large lump of stone, or whichever it is. But the corrosion of the iron is a problem. It's jacking the stones apart and loosening them. And of course, it's wasting the iron. So quite what strength there is left at the abutment is difficult to tell. And the right-hand view shows a much more minor problem. You can see on the further rib there that the end of the spandrel casting has been jacked up by corrosion. So it's split away from the arch rib. And the one in the foreground is actually broken at that bolted joint. So there are minor defects, but the only one I'm seriously concerned about is this corrosion of the iron and the state of the bearing of the ironwork in the abutment. If that goes, you lose the bridge, it collapses. There's quite a lot of, there's a lot of deterioration of the balustrade, all sorts of details. Now, all of this can be put right, but the cost is substantial. And the resources have never yet been found to do more than tinker. In 1800, the bridge was at the leading edge of iron technology. But it was soon Wilson's designs, which were derived from a masonry precedent, were soon replaced by those essentially of Thomas Telford, who didn't take the same approach that you could build it like a stone bridge, but make everything an outline of iron. He designed bridges that were essentially iron bridges. And he tackled some of the problems which Wilson hadn't recognized, but which did come to the fore in his Sunderland Bridge, principally that of bracing the ironwork so it didn't try and get out of the way of the load it was carrying, buckling sideways and so on. Telford was also much better at foundations, so a lot of his bridges have survived. The cast iron was used in Jamaica roughly over the same time span as in the UK, from the middle of the 18th century into the early 20th century. However, most of the early uses were generally in the machinery used to process sugar cane, water wheels and their shafting, cane crushing mills, boiling vats, and so on, which, like all industrial process machinery, tends to be regularly upgraded, replaced, or recycled as scrap iron. And so that sort of industrial equipment doesn't often survive unless they are left abandoned and left to decay. whereas cast iron in bridges and buildings has survived rather better. And Jamaica has some really fine cast iron structures dating from the early 19th century. Less prominent, but much more ubiquitous, is the use of cast iron for components of buildings that are otherwise of masonry and timber, for brackets and bearing places, plates, and so on. And along the uses of cast iron, wrought iron was also widely used, and over a rather longer time scale before it was replaced around 1900 by steel. Turning in a bit more detail to the former Royal Naval Hospital, this arose from the need, it arose from the mortality of sailors who turned up, were posted to Jamaica, and principal among the diseases that affected them was yellow fever, but there were also problems with malaria. And I think Nelson, he had a short posting in Port Royal, and I think I'm not quite sure which disease he got, but anyway, Nelson suffered. So quite early in the 19th century, the Royal Navy embarked on a process of investment in health facilities at a number of its naval bases around the world. And this is one of the largest, if not the largest, because of the importance of the Port Royal Naval Base. Structurally, it's very simple. It's not very simple, but it's fairly obvious from this that you can see there's a series of regular cast iron columns carrying iron frames. In this case, the roof, at this time, the roof was of wooden shingles. And then underneath that, there are these brick walled blocks separated by cast iron staircases that run up to the first floor between them. There's a lot of other materials in it. Of course, there's timber piles set into the ground and various bits of concrete and stone. But for our purposes, it's the kit of parts that's the most interesting. The building was designed by the Royal Navy's architect, a man called Edward Hull, who was very familiar with early 19th century industrial technology and used it very widely and very effectively in his buildings, and quite a number of them survive. Here's the building still in the 19th century. You can see the impact of the jalousie screens at first floor. For those who are familiar with early 19th century industrial architecture in Britain, that repetitive module, it gives the thing an appearance, really I think, quite an elegant and effective, attractive appearance. You can also see a man in a pith hat standing in the arcade of the ground floor. Sadly, all those jalousies have gone, and the very generous gallery space around the wall blocks is now entirely open. You can see the recess in the columns on the left where the jalousie screens would have fitted. It's a sad loss. I mean, obviously they could be reinstated. There are other problems which I won't go into in great detail, but as you can see, that walkway provides, or that gallery provides, a very pleasant space. The roof was stripped off in 2015, really trying to respond to the imminent cruise ship terminal, which in 2015 it was already 2020 was already complete, but of course it didn't get much used during COVID, but I believe it does now receive one or two fairly small cruise ships a month, but the inhabitants of Port Royal aren't very enamored of it. It doesn't seem to have made much difference to their well-being and lives. As happened in Falmouth, essentially the the people on the cruise ship don't engage with the local life. They remain within the terminal and do their shopping there. So the people of Port Royal are sort of rather, well, very lukewarm about it all. Anyway, it was very interesting to see it stripped back. And here's the section of it showing it's not very clear, but you can see the masonry block in the center, and you can see how much of the proportion of what I proportion of the volume of the building is actually fresh air between bits of cast iron and wrought iron. The roof frames are not, as you saw from the picture before, the roof frames don't line up with the columns, and so the gutter beams have to span the loads from the roof back to the columns. I put rings around those two positions because they'll come up later on in my talk as places where there are problems for this building. Anyway, back to the ironwork, you can see it's really, there's nothing very big up there. The roof has common purlins, those little flat bars of wrought iron that span across between the roof frames, and the roof frames themselves are mostly of cast iron, but the vertical piece you can see sort of half top, top half left, that's of wrought iron because it's under tension. And the pieces of cast iron are just simply socketed together and then bolted. You can see here that there's the ridge beam carries on over onto the slope where there's a halved joint to the principal rafter running down the slope. And you can also see the little clamping detail that holds the purlins onto the top of the principal rafters. The other deterioration, a few of the floor beams have fractured, and this one has been repaired. And you can see on the right the degree of fracturing of the masonry, of the brickwork of the wall blocks, which, well, I'll carry on. At the corner of one of the wall blocks, I came across this, and this is the bearing plate for one of the main floor beams. And you can see that the bearing plate was originally in one piece, and it had a flat plate with two upstand pieces to grip the beam on either side. And you can see that the rusting of the iron has blown apart the bearing plate and the brickwork. It's just the rust of the rust that forms on iron occupies a volume of up to 7 times the volume of the iron. And so it can exert very large forces to jack things apart. And I'm afraid that's what's happened here. But this is exacerbated because the brickwork is soaked with salt. And so you have the iron is sitting there trying to hang on in highly corrosive conditions, sometimes wet and always salty. And it's very difficult to know what to do about that. In order to remedy it, you essentially have to take all of these details apart and put in a new cast iron shoe, or new shoe, probably not of cast iron, which can resist the corrosion. And you also have to treat the end of the cast iron beam against corrosion. And then you've got to find a way of rebuilding the brickwork around it. It's doable, but it's by far from simple. Another problem, oops, now what's happened here? That's not quite what I was expecting. Anyway, on the right-hand side here, you can see the end wall block at the southwestern end of the building. And you can see there's a continuous crack running around the building just above the window heads, and with 2 large patras plates for ties on the left. And of course, those ties are also of wrought iron, probably, and they're embedded in the brickwork. The brickwork's got wet and salty, and they too have corroded, and they've just jacked up the whole of the end of the whole of the end of the building. And so you might picture the degree of dismantling and rebuilding that would be required to sort that sort of thing out. Also in Fort Charles is another rather more sinister piece of cast iron. And this is the pivot for a very large gun that was put in, I don't know whether it was late 19th century or early 20th century, put in this gun emplacement. All the vegetation behind, of course, has grown up since. And it's just a reminder of the great variety of uses to which cast iron could be put. Also in Port Royal, here's this rather elegant tomb, actually. It's the only one in the cemetery which is graced by its own railing, and it's in surprisingly good condition. The tombstone itself is of imported marble, and all the ironwork was certainly imported. Another example, rather different, and this is the Scots Kirk in Kingston, which has a series of columns around the outside, has these 3 porticos on the street side and north and south of that. And then inside, the elliptical auditorium of the church, which runs right round the interior, is supported on a series of columns which are beautifully clad in wood, but which contain large lumps of cast iron. And you can see here in the detail on the right that one of the capitals has got blown apart, perhaps by corrosion, I don't know, and exposing the substantial iron casting within the column. So iron being used as a structural support and disguised. Of course, that's the kind of thing that Hull would never have done. I think this building is from the 1840s, but I can't remember. So Hull used the iron in the best way he could as it came out of the foundry. And here, that wasn't deemed sufficient. Other uses, water wheels. And this is just a representative of the industrial machinery that the estate production of sugar and rum would have required. And this poor thing has ended up stranded by the North Coast Highway. There's still the vestiges of a water wheel within its housing, and the aqueduct bringing the water to it, which came from the right in the lower right slide, that's all vanished because it was an overshot water wheel. And the machinery, all that it drove, would have been in the buildings to the right, of which their only vestiges remain, just stumps of walls. But some of the wheel itself survives. And again, you can see a series of castings, a cast iron shaft, cast iron discs wedged onto it, cast iron ribs bolted to it, and then the so-called shroud, the big ring of castings around that held the buckets, as they're called, around the outside of the wing. They're all cast iron and in very good condition. So this is just a representative of the kind of machinery that would have been imported. Here's a drawing for one such wheel for the Mona estate. There's not much detail of the wheel, but you can see its shaft was drawn in rather more detail. Obviously the wheel fitted into the big pit and drove the cogs which were above it. It's quite interesting, I think, that this drawing survives from 1864 in the University of Glasgow archive, and it was reproduced in Suzanne Frances Brown's book on the Mona campus, on the history of the Mona campus. And luckily she had a scan which she could send me. And here is the estate, the crushing mill around 1900. You can see in the background, you can see the timber launder, as it's called, the final section of the aqueduct that delivered the water to the wheel. You can just about make out, well, you can make out a quadrant, a segment of the wheel with the castings bolted together right at the left. And then between the wheel and us, there's a really large gear wheel, and that's driving a shaft which turns the crushing mill in the foreground there. I'm not quite sure whether it was operating or not, but you can see a man standing on top of the aqueduct in the background, which suggests that somebody was about to release the water and get it all turning or something like that. But you can see cast iron used for pretty well everything you can see in one way or another. You know, the water wheel, the gear, the shaft, and the fairly massive frame of the crushing mill, because obviously the forces generated could be quite substantial. The water wheel's housing, is now essentially below ground in one of the very nice gardens on the University of the West Indies campus, which they call the Mona campus, though it in fact includes quite large chunks of the Papine estate as well. But you can see there's not much trace of the water wheel left now. Another example here, now we're getting into slightly more congenial territory in a way, because this is a demonstration of civic pride by people who probably weren't settlers. Mr. Moses Bravo persuaded the St. Catherine's parochial board to procure this clock. It had been earlier suggested by Mr. Granville Goldsborough, and the proposal was this is from Moses Bravo, proposed it should include a laveo for the general use and convenience of the inhabitants of the town of Old Harbour. I assume a laveo was a public convenience, but it's not a word I've come across before. I suspect, but without any evidence, and I haven't looked it up, that both Granville Goldsborough and Moses Bravo came from the Jamaican Jewish community, in which case it's rather nice that it's very commendable that they felt sufficient civic pride in the town of Old Harbour to want to dignify it with this clock, which is a rather splendid fabrication, as you can see. And the people of Old Harbour look after it really quite well. I think it was showing the correct time, but I'm not sure about that. Other clock towers were built. There were in fact two of them, one in Chapeltown and one in May Pen, both in Clarendon. But they were erected in stone and functioned as war memorials to the Jamaicans who died fighting for the United Kingdom in World War I. So the passage of time and the function of the clock used as a way of reminding you or reminding people of the local people who'd gone off and were killed. Now this is the rather wonderful and completely zany Zane's tobacco shop and cigar manufactory in Kingston, photographed a few years ago by Chris Louis, who sadly has since died. And you can see that there's this very florid and highly decorative cast iron frame. And Habib Najib Sain is give another little illustration of Jamaican history. Quite a number of people went to Jamaica from Syria and Lebanon in response to Muslim assaults on Christians under the Turkish Empire. So it's rather nice to think of Jamaica at that time being seen as a place of safety for people fleeing persecution. And Habib Zain did all right. He carried on. I'm not sure when he died, but as you can see, he anyway, I can't remember, I've got it on there. Oh, yes, right, cultivation of Virginia tobacco. He started this up and made a real go of it. So all power to Mr. Zane's elbow. As you can see, it really is very ornate. And sadly, when Chris took the photographs, in really poor condition. On the left, there's a lamp bracket, and you just wonder what sort of a lamp would have hung from that, presumably an electric lamp. And on the right, there's a couple of, well, several bits of several cast iron braces are visible. I'm not quite sure how structural they would have been, but they certainly were intended to give some semblance of a structural action, bracing the beams against the columns. It all came from Glasgow. And although the ornament seems rather florid for the 1930s, the Saracen foundry in Glasgow carried on producing cast iron up until the 1960s. So it's possible that this frame was bought by Mr. Zane in the 1930s to celebrate and to house this successful tobacco business. And I just think that's rather a nice change of emphasis from the kind of way we usually think of for, people in Jamaica. Just a little, not quite a postlude, but this is the former beehive kiln in Falmouth, which was used for a variety of hot processes, starting probably as a bottle kiln or perhaps a ceramics kiln. And those of you who are familiar with the bottle kilns of, or the beehive kilns as they're called, of Stoke-on-Trent will recognize the shape. But Ivor Connolly and somebody whose name I can't remember, carried out an archaeological investigation of the site and showed that it almost certainly in the later 19th century housed a cupola furnace, which is a small, not portable, but a transportable furnace. And that was used to recycle cast and wrought iron items into new items. And they know this from the slag, the iron slag that they found in the deposits on the floor. And here's a rather spectacular photograph showing a modern cupola furnace being tapped. And you can see what I said about brilliant orange heat. That iron is pretty brilliant. So that would have, there would, at the end of the 19th century, beginning of the 20th century, there probably was some small scale production of cast iron in Jamaica, but I'm afraid I've never been able to identify anything that was produced at that time. And now to sum it all up, this extraordinary chart was produced over 20 years ago now by some economists, American economists. They were trying to understand why former colonies had ended up with such different degrees of affluence of their current populations. And the only measure for which they could get data that fitted in any sort of sensible, statistically sensible way was the evidence of the mortality of the settlers in the 1830s, because that's when records started to be kept. And you can see that I've ringed Jamaica in red, so it's sort of halfway down or halfway up, is where you look at it. And you can see that despite the incidence of mortality in Jamaica being significantly worse than that in Pakistan and India, and quite a lot worse than that in Ethiopia, the two rings down below to the left, they have never achieved the kind of GDP per capita that Jamaica has achieved. And right at the top left, you can see the healthiest places, which ended up with the highest GDP per capita. The highest of all being the USA and Canada, and I can't remember what else is in that ring. But the lowest mortality, Australia and New Zealand, and the worst mortality in poor Malawi down there at the bottom right. So if you go to a colony and you find that you're at risk of dying, what you do, if you can, you go back home, you send an attorney to run the estate for you, and you devise mechanisms for getting the money out of the island back to Britain. And perhaps the most pernicious of these institutions was the use of enslaved labor. When the British first colonized Jamaica in the first estates, they tended to use British labor. It didn't last for very long because they first of all, they didn't like the work, and secondly, they tended to die. So the thought was that enslaved Africans from West Africa would have more resistance to some of the endemic diseases in Jamaica. And so they started importing them. And of course, this became a massive industry. But it did mean that investment in the colony was reduced. Now, those people in Australia and New Zealand and the USA, because they could live there very healthily, they were quite happy to object to sending taxes back to the UK and to invest it in their colony so that they boosted their own wealth without the inconvenience of having to take it somewhere else. And this dichotomy of the motives behind the production of wealth on the island it still persists. Unfortunately, the kleptocratic institutions that the British set up in order to make sure they could get their wealth back home, that has to a large extent been continued in the way in which wealthy Jamaicans can become a great deal more wealthy than a lot of the population around them. Okay, I'd just like finally to thank many people in Jamaica who've helped and befriended me. I say particularly Suzanne Francis Brown, Peter Francis, Anne Hodges, another architect, and Ivor Connolly. They're all of those, I value these people. They've been a great help. And thank you also to all of you for joining the meeting. And if you wish to get in touch with me to object or whatever, there's my email address. Okay, thank you.
Andrew, thank you so much. That is absolutely riveting, and I suppose riveting is an appropriate word to use in connection with metalwork, isn't it? But thank you also for your little bit of social history at the end.
I'm sorry, it was rather over length in the end.
Well, it was good. Are there? No, it was every bit of it was interesting, and thank you. Are there? I haven't seen many questions in the chat box, but can I ask one something that I ought to know, because it's not cast iron, but where were all the railway lines made? Were they all imported?
They were all British, as far as I know.
Yeah.
By that stage, the proportion of cast iron would have been relatively small in the permanent way, but the rolling stock, particularly the locomotives, would have probably had cast iron frames and so on. So there's probably quite a lot sitting around in sheds and other things, rusting slowly.
And indeed locomotives, presumably.
Yeah, yeah.
Would have been had cast iron. I was your close-up pictures of the Naval Hospital were fairly dispiriting. And how, I mean, how do you repair cast iron? Do you have to stitch it?
Yes, and there are quite a number of quite serious problems. One of the basic ones is that the weight of the wall blocks has caused them to settle into the ground further than the relatively light perimeter of the building. And so any rain or seawater or spray that falls on the balcony drains towards the center. And so there's a system for pumping salty water into the masonry of the wall blocks. So one of the things you have to do is to resolve that, and obviously enclosing the balconies at first floor in a way that excludes the salt would start that process.
Right.
Then,
yeah.
But then I didn't go into it, but the roof frame has actually racked sideways. As you can see, those purlins, little common purlins, don't give much restraint to the principal rafter moving sideways, and particularly when you undo all the clips in order to do some work on it. And so the thing sort of sags sideways a bit. In the process, that has broken some of the sockets into which the members of the iron sit. There's a number of, there's quite a tally of repairs. They can all be fixed, but it's again, the investment is.
It'll require a deep pocket. Yeah.
And one of the problems is that the expertise that's needed isn't available on the island. So now there's a question from Selina.
Yes. Thank you. I was going to draw your attention to that, but yes, the question is about the use of the material over local stone materials. Was it about creating a market for UK export?
In the case of the iron, yes. It's quite interesting because there's some evidence that the demands of the agriculture on the island actually led developments in iron machinery in Britain. It's not very, but the two definitely went hand in hand. So the needs of the industry on the island went hand in hand with the new devices, new mechanisms devised in the UK. There is some British stone and some British bricks on the island, but because the island is so wonderfully supplied with limestone of various qualities, most of the stone was quarried locally. The only things that I can see that came out from Britain were limited components from limited pieces of stone for the naval hospital and some of the other structures in Port Royal, and it may well have arrived there as essentially as ballast in a ship. Bricks, of course, were clearly made on the island until relatively recently, and Dr. Connolly is hoping to revive brick manufacture.
Indeed, he started.
Yeah.
Andrew, I know there are two more people wanting to ask questions. One is Steve Porter, and then Jonathan Greenland. So Stephen, do you want to fire away?
If it's not too difficult, could you stop sharing so we can see everyone a bit better?
That's a good idea.
Is that okay? Lovely, thank you.
Brilliant.
Sorry, didn't think of it.
Yes,
Sorry.
so Stephen.
Oh yeah. it was more to tell Andrew about something he queried earlier. The DH Wint that you mentioned.
Yes.
Yeah, his full name is Douglas Howard Wint, and he worked for the Public Works Department in Jamaica. He's Jamaican born. And I can send you 2 biographies of him from different publications. So it gives you the background to his
Yes.
his engineering capabilities. But he was trained abroad.
Yeah, I mean the Iron Bridge is not easy to survey. Making a dimensional survey of that using tape measures and so on would have required quite a lot of effort. As I tried with Peter Francis, and it's really quite difficult to take any meaningful measurements. But he obviously did have the right surveying skills and equipment to make a proper job of it, because that elevation has proved remarkably accurate.
Yeah. It says he was the director of major projects in Jamaica at the same sort of time period you're talking about there.
Right. Well, thanks, Stephen.
So,
Yeah, it's good
so
to know.
I'll send you this stuff. And it's a lovely, I really enjoyed the talk. Thank you very much.
Oh, thank you. You're welcome. Yeah.
Jonathan, would you like to fire away?
Yes, thank you, Peregrine, and thank you very much, Andrew. Fascinating talk. I think, as you know, well, I'm interested in all those things, but particularly at the moment in the Naval Hospital, which, as we all know, is in dire state. But we do need to. They're kind of interested in Edward Hull. It's a shame Edward Sargent isn't on this call, because he knows so much about Edward Hull. He gave me a wonderful tour of Chatham Dockyard, which is obviously where Hull was based, and showed me some of Hull's structures and also the sort of work of Marcel Brunel and stuff like that. So it was absolutely kind of fascinating tour, and he brings a lot of knowledge to that. But I'm kind of curious, because those of you, been to Jamaica or lived in Jamaica, and those of you been in the UK know that there's a vast difference in the environments. And it seems kind of amazing that Hull was able to kind of envision that temperature and the sun and the breeze and stuff like that. Is there any knowledge about where he got some of his training? Did he go to places like Gibraltar or Malta or anything like that, where he would have got a sort of small flavor of the conditions? Because, as we know, the Naval Hospital is brilliantly designed and constructed and configured. So I was kind of curious about that. And also, I'd done some work on the kind of actual construction of the Naval Hospital. I'm not sure if you mentioned it, but there was a Naval Hospital there before, obviously, and it was burnt down. It was wooden, and so there was a sort of a whole campaign. I mean, I originally thought that they sort of pre-packaged all this thing like in IKEA and sent it over, and then they just constructed it. But it was actually kind of quite a long process, and they had to buy up a big section of the town off private people in order to make those wonderful gardens that we see now. That is a sort of a fascinating process, because they had to go to tender, they had to find local contractors, and to do every little bit of it, the wall, the sea wall, and the structure itself, which originally was planned to have 2 extra bits which would have wrapped around a little bit. I think you mentioned that, but would have been interesting to see. There's a diagram of it, I think, in the Kew archives.
Right.
Yeah, which shows a sort of, it wrapped little wings to it as well, which were never built, obviously. So anyway, most importantly about Hull, if you know anything more about him, I'll be very interested.
Well, have you come across Jonathan Code's book, Support for the Fleet?
I have, yes.
Yes, I can't remember what he says about Hull in there. I don't know of a biography of Hull, but he was a very able designer. I don't, as far as I know, he didn't travel widely himself, but I haven't looked into it. But I think the system of conveying a brief from people serving in Port Royal and other Caribbean stations back to Britain, I think there's a good chance that quite a lot of features of the building would have been set out as requirements. And as you know, the Jamaican National Archive contains some drawings of the earlier scheme with a pair of wall blocks either side, a smaller wall block either side of a central walkway, and then what looks very much like tacked on balconies either side with flat roofs. And I mean, Oliver Cox deals with this in his little monograph on the naval hospitals. So at some point that design was abandoned, and I guess that would have been because of feedback from people who knew what it was like in Jamaica. And of course, a lot of the sailors of the Navy would have served in Jamaica one way or another, and quite a lot of soldiers too on the land.
Thank you.
I would guess that there is a biography of Hull, but I haven't come across it.
Okay, no, neither would I.
And as you say, he's quite a significant figure, and Chatham Dockyard is a wonderful memorial to his work.
Yeah, I agree. Maybe Peregrine, maybe the Commonwealth Fund could support.
Well, I was going to say someone needs to write a biography. So who's volunteering? Anyway,
I think Edward Sargent should probably be consulted on this, but
yes. Well, listen. I mean, would he be interested? I think because he could contribute a lot. We can send him the recording if he wants to listen to it, because he might. Yeah. But as I'm sorry he wasn't here.
And I know Edward fairly well. I could write to him and say, does he know of a biography of Hull? That's no problem. Yeah.
Okay. I think that's been terrific. And unless there are any more questions, I think we might perhaps wrap up. But thank you all for joining us. Please join the talks that have come, including one I can't remember later this month, on the Scottish foundries that provided a lot of the cast iron, by Ali Davis, I think. But there are lots of others about cast iron around the world, and look on the Commonwealth Heritage Forum website and you will find the links. And Andrew, thank you really for a fascinating talk. And we learned a lot, and led to a certain amount of sort of this concern that we all share for the future of the heritage of Jamaica. But we fight on.
Yes. Thanks, Peregrine. Yeah.
Farewell all, and thank you very much.
Thank you. I have put the link in the chat for the other talks if you just want to have a quick look before we finish. But
thank you for doing that, Rachel. Yes, wonderful.
Have a good evening, everyone. Thank you for joining us. I'm going to stop the recording.
Farewell. Yep. Bye, Jonathan.